Hi, students. So in this Edpuzzle, we are going to be accomplishing on our downloadable handout, which should be titled Investigating the Effects of Distance on Magnetic Force. We're going to focus in this video on getting our hypothesis answered, which is our cause-effect relationship we want to test. Right? That's part A. But then also our part B, which is what are we going to change, measure, and keep constant? More of those variables. Okay. So to do this, I have a PowerPoint that we are going to work through, and I'm going to hit present and kind of talk through this investigation with you, and then we're going to work together to get a lot of the elements on our digital handout completed. So as you work through this, make sure that you have your investigating the effects of distance on magnetic force, made a copy of that document, having it out to fill out as we go through this video. Okay. So obviously in here, we're going to do an investigation where we see how does distance affect magnetic force. And one of the tools I want to introduce to you is we're going to be using a digital scale. And the purpose of this digital scale is to quantify the force that we're experiencing. So digital scales actually, they don't measure weight that we might think of. They actually quantify how much force is present. Okay, they quantify the force that something exerts downward due to gravity. And we see that in this description here. And I have in here that weight is actually a measurement of force. Okay, so when a person steps on a scale, the scale is actually measuring the net force of the person's body being pulled down towards Earth. Right? So an object's weight is a measure of that downward force. So we're going to use this tool to help us figure out how much force are magnets exerting on each other at different distances. Okay. All right, so next part is we want to focus on coming up with a hypothesis. So oftentimes, before we investigate the relationship that we're going to investigate, we need to come up with a hypothesis of a prediction of what we think is going to happen. All right. So right now we're going to develop a cause-effect relationship that we predict will tell us something about the effect of distance on magnetic forces. Okay, and our theory right now is that. All right, our theory right now is that distance does affect magnetic force. So we're going to figure out when we do something, what are we going to see happen? Okay, so thinking about our magnets, what do you think is going to happen as we change the distance? All right, what are your thoughts on what can we do with our magnets, and then what effect will that have on each other in regards to force? All right, so now that you've thought a little bit about that, maybe share out your response. We're going to record a hypothesis in our notebook. So on our document, all right, I'm going to exit out here. I'm going to go to my document. On here where it says the cause-effect relationship we want to test, we are going to type in and we are going to test this cause-effect relationship. So we want to write in if distance affects magnetic force. And again, that is our explanation or our theory. Now we're going to put in our cause, and our cause is then when we move two magnets closer together, now we're going to insert our effect. And further from each other, we will observe the force on the scale changing. Okay, so I will simply put though there that if distance does affect magnetic force, when we move two magnets closer together and further away from each other, and we change those distances, what should we see? We should see the force change. Okay, and in here, I'm going to show us that this part right here, that part right there, that orange part is our explanation or theory. This part that I'm highlighting is our cause. And then our effect is going to be in the color blue. So notice we've got orange representing our explanation or theory, the green is representing our cause or the change we're giving, and the blue is representing the effect that we're going to be looking for. Okay. All right, so I'm going to go back to my slide now. So now that we've figured out what our hypothesis is going to be, we need to go back to our slide and we need to continue on. Okay, so we've got our hypothesis figured out. now we want to start designing our investigation. In order to design a good investigation, we need to know what our variables are. So I want to introduce to you kind of the system we plan on using. Okay, so in the system, here we see we've got a scale. On the scale, we're going to have one magnet, and we're going to tape it to it so that it can't move. Okay, above that, we're going to have a set of 4 magnets, right, that we're going to move at different distances. And you can see we've got a ruler back here or a meter stick to help measure that distance. And that's going to show us the distance between those magnets. And then again, the scale is down here to help us show what force are we seeing in that push or that pull, depending on how we orient our magnets. So in this system, I want us to think about what is going to be our independent variable, what is going to be our dependent variable, and what are some controlled variables in here. So let's start first with the independent variable. Remember, that is the change we make to test, or change we make the system each time we test. So in here, what's something that we're going to change? And then I want us to think about the dependent variable. In here, what are we going to be looking for? All right, what is the variable we're going to observe or measure for effects caused by a change in the independent variable? And then lastly, when we think about the controlled variable, what do we want to keep the same amongst each of our tests? All right, what do we want to keep the same? So now that you've had some time to think about those, let's go ahead and go back to our document sheet of this handout, and we want to fill in what are our variables in this test or in this investigation we're going to do. Okay, so our independent variable in here is actually going to be the distance between the magnets. We're going to measure that in centimeters. Okay, remember, our independent variable oftentimes fits with whatever our cause is. So I'm going to highlight that as green, and you don't need to do this part, but just so you know that generally speaking, our independent variable is what our cause is. It's our change. Okay, so here we're moving 2 magnets closer together and further from each other. In short, right, that's the distance between them that we're changing. What we're going to be looking for, and I will fit this part in here, what we're going to be looking for is the force of the magnets. And we're going to measure that in ounces. The abbreviation on there. So I'm going to put OZ for ounces. And we're going to So notice how this portion is what we have as the effect, right? So we've got that blue color there, right? Our observations is the dependent variable. Is what we're looking for. And then lastly, what are some controlled variables? So in these tests, what do we want to keep the same each time? Right? And some ideas that I came up with was we want to keep the type of magnets the same, right? We want to keep the location in the room the same. Individual roles need to be the same amongst these group members. So those are some things that might affect our results in the investigation. And that doesn't correlate to any portion of our hypothesis, right? But that's something separate we think about. All right, so now we have come up with a hypothesis and we've determined our 3 variables, okay? Don't worry about this writing here at the bottom, but this is the end of the video. So now after this, you will be going on to the next video where we're going to work on making some predictions about what we think we're going to see. All right. So now you can finish up this video and go on to the next one.